There is a place in our solar system where rain does not fall as water, it falls as fuel. Where rivers flow with methane, mountains are not made of rock, but of ice as hard as steel, and temperatures are cold enough to freeze every form of life we know. And here's the shocking part. NASA believes this place may have a higher potential for life than Mars. This place is not a distant planet. It is Titan, the largest moon of Saturn. Now let me ask you one question. If life doesn't need oxygen, doesn't need water, and doesn't need warmth, then what could be living on Titan right now? NASA has discovered things that left scientists speechless. But what's even more frightening is what they still haven't been able to confirm. And after hearing this story, you may never look at life the same way again. Welcome and the mystery of Titan. Welcome and thank you for being here. This channel is still very new, but our journey has already begun. A journey to explore the strangest and most fascinating mysteries of the universe. If you're curious about space, science, and the unanswered questions that keep scientists awake at night, you're in the right place. Feel free to share your thoughts in the comments and explore this journey together with us. Hidden beneath thick orange clouds lies Titan, a world that has remained out of reach for decades. For a long time, its surface was completely invisible, sealed away behind an impenetrable haze. What scientists suspected was extraordinary, a place that feels strangely familiar, yet completely alien at the same time. A world shaped by forces similar to Earth's, but operating under rules we are only beginning to understand. And for many years, Titan kept its secrets well hidden. The history of discovering Titan. In fact, Titan is not a new name to humanity. This moon has been known for centuries and was officially discovered in 1655 by the Dutch astronomer Christian Huygens. True to its name, Titan is enormous. It is larger than Earth's moon and only slightly smaller than the planet Mercury, making it one of the largest moons in the solar system. However, despite its size, Titan is incredibly distant. For hundreds of years, it appeared only as a faint, blurry point of light in telescopes, revealing almost nothing about its true nature. That began to change in 1979 when NASA's spacecraft Pioneer 11 flew past Saturn and its moons. Scientists were eager, hoping this mission would finally reveal Titan's surface for the first time. But what Pioneer 11 actually saw was something unexpected. A thick layer of orange clouds, completely hiding the world beneath, as if Titan was still guarding its secrets. A terrifyingly Earth-like atmosphere. What Pioneer 11 managed to discover was not Titan's surface, but something far more unsettling. Surrounding Titan is a thick, dense atmosphere, rich in nitrogen. In fact, nitrogen makes up the majority of Titan's atmosphere, just as it does on Earth. This immediately caught scientists' attention, because nitrogen is not just a random gas. It is a key ingredient in the complex chemistry that supports life. On Earth, a nitrogen-rich atmosphere helps regulate temperature, protect the surface, and allow organic molecules to form and interact. Seeing a similar atmospheric composition on Titan raised an uncomfortable question. What if Titan is not as alien as it looks? Despite its freezing temperatures and distant orbit, Titan possesses an environment that feels strangely familiar, a chemical setting where the basic reactions of life could take place. But this discovery only deepened the mystery, because an atmosphere like this should not exist by chance alone. If Titan can sustain such a thick Earth-like atmosphere, then something powerful must be shaping and maintaining it. And that realization led scientists to search for something even more unexpected: methane and hydrocarbons, the foundation of life. To understand why Titan has captured scientists' attention, we need to look at one crucial concept: hydrocarbons. Simply put, hydrocarbons are molecules made of carbon and hydrogen. They may sound unfamiliar, but in reality, we encounter hydrocarbons every single day in gasoline, natural gas, and many common fuels. What makes Titan remarkable is that its atmosphere contains enormous amounts of methane. Methane is a simple hydrocarbon, but it plays a powerful role in the chemistry related to life. On Earth, carbon is the backbone of all living organisms. DNA, proteins, and countless complex biological molecules are all built upon basic carbon structures. So when scientists discovered a world as rich in hydrocarbons as Titan, it immediately raised serious questions. In other words, Titan possesses the basic building blocks needed to assemble life, even if that life does not resemble anything we know on Earth. Then came a small but unsettling discovery. Within Titan's atmosphere and on its surface, scientists detected traces of oxygen, extremely small amounts but undeniably present. This finding changed everything, because oxygen does not easily exist alongside methane without being constantly replenished. Its presence suggests that active chemical processes may still be occurring on Titan today. And that leads to a disturbing question. If Titan has carbon, methane, and even a hint of oxygen, then where is this oxygen coming from? And where is it hiding? That single question pushed scientists to look deeper beneath Titan's surface and marked the beginning of an entirely new search, one that would uncover even stranger secrets hidden beneath the ice. Strange gravity and the possibility of flight. As spacecraft flew past Titan, scientists began to notice something unusual about its gravity. Despite being much larger than Earth's moon, Titan's gravity is weaker than expected. This strange detail revealed something important. Titan is not very dense, and it is not made entirely of rock. Instead, much of its interior appears to be composed of ice and lighter materials, hidden beneath its frozen surface. And this leads to a fascinating thought experiment. On Titan, with its low gravity and thick atmosphere, a human wearing a wingsuit could theoretically glide through the air for an incredibly long time, far longer than on Earth. Flight would feel slow, smooth, and almost effortless. This combination of conditions makes Titan an ideal world for flying machines. Not planes, not rovers, but drones. Devices that could hover, glide, and travel vast distances above the surface, quietly observing a world shaped by forces both familiar and completely alien. And that realization would soon inspire one of NASA's most ambitious missions yet: Cassini and the Major Turning Point, 2004. The true turning point in our understanding of Titan came in 2004, when the spacecraft Cassini finally entered the system of Saturn. This mission was a large-scale international collaboration between NASA, ESA, and ASI, one of the most ambitious space exploration projects ever attempted. Cassini was equipped with radar and infrared instruments, allowing it to see through Titan's thick orange clouds, which had hidden the moon's surface for decades. Over the course of its 13-year mission, Cassini flew past Titan 127 times, gradually peeling back the layers of mystery surrounding this world. What Cassini revealed stunned scientists. Titan possesses an atmosphere several times denser than Earth's. Even more surprising, this atmosphere produces a phenomenon known as the anti-greenhouse effect. Instead of trapping heat like Earth's atmosphere, Titan's dense haze blocks much of the sun's warmth from reaching the surface, plunging the moon into extreme cold. Yet within this frozen environment, unexpected geological and chemical processes were found to be actively shaping the surface, signaling that Titan is not a lifeless world, but one quietly evolving in ways unlike anything we have ever seen. The methane cycle, rivers, lakes, and seas. As scientists continued to analyze the data from Titan, an extraordinary picture began to emerge. Titan does not have a water cycle like Earth. It has a methane cycle. On Titan, methane falls from the sky as rain. It flows across the surface in the form of methane rivers, carving channels and valleys over time. These rivers collect into lakes and even vast seas of liquid methane and ethane spread across the moon's surface. All of this happens at an average surface temperature of around 179 degrees Celsius, cold enough to freeze water as solid rock. But under these extreme conditions, methane behaves the way water does on Earth. It evaporates, condenses into clouds, and rains back down again. This makes Titan truly unique. As far as we know, Titan is the only world beyond Earth where stable liquids exist on the surface today, not trapped beneath ice, not appearing briefly before disappearing, but flowing, pooling, and reshaping the landscape over long periods of time. To imagine Titan, picture Earth, but replace water with liquid natural gas. Imagine rivers flowing not with water, but with fuel. Lakes that never freeze solid because methane, not water, is the liquid that rules this world. This strange parallel to Earth is what makes Titan so compelling. It is not just an icy moon, it is a fully active world, running a familiar planetary process under completely alien conditions. And that realization forced scientists to confront a powerful idea. If a world can look this alive without water, then perhaps life itself may not be as limited as we once believed. Huygens' lens, familiar and terrifying. In 2005, for the first time in human history, a spacecraft touched down on the surface of Titan. It was the probe Huygens, released from its parent spacecraft, Cassini, after a journey spanning billions of kilometers. As Huygens descended through Titan's thick orange clouds, the first images it sent back caused scientists around the world to fall silent. Below lay a landscape that felt unsettlingly familiar. Dry riverbeds, winding drainage channels, and smooth, rounded pebbles, almost indistinguishable from those found on Earth. But the truth soon revealed itself. And it was colder than anyone expected. Those stones were not rock, but water ice hardened like stone. Those rivers had never flowed with water, but were carved by liquid methane over thousands of years. Even the surface that looked like mud was made of frozen hydrocarbons, showing no signs of life. The moment was both breathtaking and deeply unsettling. Because Titan looked terrifyingly similar to Earth, yet was completely lifeless at the surface. That realization marked a turning point. Titan was not a dead world. But if life existed there at all, it was hiding far deeper beneath the surface, beyond the reach of our first landing. And with that understanding, the search for life on Titan entered an entirely new and more profound phase. Lakes, seas, cryovolcanoes, and a hidden ocean. After the landing of Huygens, data from Titan continued to reveal discoveries even more astonishing. Scientists confirmed the existence of vast lakes and seas of liquid methane spread across the surface. Among the most prominent are Ontario Lacus and Kraken Mare. Large, stable bodies of liquid that persist over long periods of time. But Titan is not defined by surface liquids alone. Beneath its thick, icy crust, scientists found evidence of ice volcanoes, known as cryovolcanoes. Instead of erupting molten rock like volcanoes on Earth, these features eject mixtures of ice, water, and ammonia. And ammonia is the crucial key. It acts as a natural antifreeze, preventing water from freezing solid even at extremely low temperatures. Because of this, scientists began to suspect that a subsurface ocean of liquid water may exist beneath Titan's surface. If this hypothesis is correct, then Titan does not merely possess the ingredients for life. It may also offer a stable, protected environment where complex chemical reactions can occur over immense spans of time. This is the moment when the door to microscopic life begins to open, not on the frozen surface above, but deep beneath the ice, where Titan remains quietly active and maybe nurturing something we have never seen before. Dragonfly, NASA's final opportunity to answer the deepest questions surrounding Titan, NASA has placed its hopes on one bold mission: Dragonfly. Dragonfly is unlike anything NASA has ever sent to another world. It is a nuclear-powered flying drone designed not to roll across the surface, but to fly from location to location, landing, taking samples, and lifting off again. Titan's thick atmosphere and low gravity make this possible. Dragonfly will be able to travel dozens of kilometers at a time, reaching places no lander or rover could ever access. Inside the craft is a mobile laboratory, capable of analyzing chemical samples on site. Dragonfly will search for complex organic molecules, clues of prebiotic chemistry, and possible signs that life's processes may already be underway. The plan is to launch Dragonfly in 2028, with arrival at Titan expected in 2034. It is a long journey and a technically risky one. But for scientists, Dragonfly may represent our best and possibly final opportunity to discover whether Titan is merely a fascinating world, or a place where life has quietly begun, hidden beneath the ice. After everything we've seen, Titan is no longer just an icy moon orbiting Saturn. It is a complex world, alive in its own unique way, with a thick atmosphere, rivers and lakes of methane, a possible subsurface ocean, and enough intriguing conditions to force us to reconsider the biggest question of all: what does life truly need in order to begin? Titan may not have given us a clear answer yet, but it has given us an entirely new way of thinking about life in the universe. If you enjoy science stories told slowly, clearly, and with depth, consider subscribing to the channel to join us on future journeys. And if you have any thoughts or questions about Titan, feel free to leave a comment. We'd love to explore them together. Thank you for staying with us until the very end. We'll see you again in the next video.